I had to create a not or logic gate because the ones that are provided built in, they didn't have a NOR. They had a NAND, they had an XOR. They don't have XNOR and they don't have NOR. And so I walked through the creation of a not or, so we would have a logic gate that functions just like a NOR. So the not basically changes all the output of the OR and flips it, just like a NOR would. And instead of calling it NOR, because there are other things that Nant Tetris did for some of their activities and exercises, I don't know, I think we ran into an error at one point. So I changed the name to not or because NOR just wouldn't work. Well, here's the not or HDL file. And what I want you to do is to download it. So you're going to click on it. You're going to see this. You could copy and paste this into the text editor, right? Just like I'm doing right here. And I highlighted this, but I didn't do right click and copy. So now I've got the notepad open and I'm gonna do this. And that's the extra piece that I created on Wednesday to provide the NOR functionality for the custom logic gate that I built. And there it is. And you have it now. And what I want you to do is I want you to save as, and I want you to go into your Nant Tetris folder. Yours is going to be in a different location than mine is. But in my case, I'm going into solutions. And we're in module 3. No, solutions Nant Tetris. In the tools, in the built-in chips folder, that's where you're going to put not or. And you're going to go then and navigate into your Nant Tetris tools built-in chips folder, and you're going to change the TXT extension so that it reads HDL. And I've done that here. So I have a copy of that here. You save that text in your built-in chips directory, and then you go into the built-in chips directory after you close Notepad, because if you try to do this while Notepad is open, it will not work. So if I tried to change this right now while this is open, it would say, the file's in use. You get some weird message. You're going to click on it. You're going to take the last TXT off. And instead of reading not or dot TXT, the last part is going to read not or dot HDL. So you'll delete and then replace TXT with HDL. Any questions on what you do? Just remember, if you have a problem working your solution, use caps on the first letters. We call that title case or camel case, right? And then the rest of the letters in the name lowercase, and that'll usually solve the problem. Okay.
So in the case you said nor would not work, because I tried that, I got an error. So not or would be the name you use.
Not or is the name that you're going to use if you want to use a nor for one of the components in your solution. So here's where we were. Let's see, before. So you're working up the truth table. You can put the canonical on the same truth table and the pseudocode logic, right? So I did get some email from students that said, I'm having some challenges with the logic, right? How do you write out the logic in plain English like it's pseudocode?
But what's the canonical again?
The canonical is the abbreviated expressions using ticks for negative values.
Right?
That stuff, right? So if you have a canonical expression, if you have a couple of canonical expressions, you can find out by looking at those canonical expressions which values are true and which are false, and then that makes the pseudocode easier to do. And we'll cover we'll share examples in just a minute. So I'm going to ask for volunteers. You know, would anybody be willing to volunteer their canonicals so we can develop the pseudocode, and we'll do it together as a class. But why are you working that up? Have you heard did you ever hear your math teacher say, you would have gotten partial credit, but you didn't show your work? Yeah. So what I want you to do when you submit your solution is I want you to include the truth table and the canonical expressions and the logic and then the HDL file, and then I want to see a screenshot, 2 screenshots, one of the true case and one of a false case. And why do I want all that? Because if you're wrong or there's a mistake, if I see your work, I can give you partial credit. Does that answer your question?
Okay.
Okay. So, and the rubric can be helpful that way. So the rubric, you want to follow the rubric. Does the basic compound logic gate include 2 or more simple logic gates? Well, you want me to be able to check yes, don't you?
Yeah.
Yeah, and then was a legible, sensible diagram. The key word there is what? Legible, and then think about sensible, right? So it doesn't have to be complicated, but it has to be legible. If it's not legible, if it's hard for me to read, then that's going to be no. But most cases, yeah. Doesn't have to be pretty, doesn't have to be fancy. You can do it with crayon, as long as I can make it out, right? Does an accurate truth table reflect the possible outputs? Now I'm going to create a truth table for every diagram I receive from you. And I'm going to see if your truth table matches my truth table. So yes, I need your truth table. And that's why the third element, you want to be able to check yes. Was the appropriate canonical type used to express each case? If you gave me 7 canonicals that were all true, or 7 canonicals that were all false, my first question is going to be, oh my gosh, do you want to make the logic that hard? Okay. So does that help? Follow the rubric, all right? As long as you can answer yes to each one of those, you're good. That's what your submission needs to show. Screenshots of what you're doing. Okay. Any other questions before we continue?
What are we doing right now?
All right, so I'm glad you asked that. I'm going to open up the HDL that I developed for the solution so that I can finish the recording from Wednesday, the last part of it. And that's where I'm headed next. So we downloaded not or. We put it into the folder for built-in chips, and then we changed the extension from TXT to HDL. So if you're using a solution that requires a NOR, like I did, you don't have to build one from scratch. You can use the one I provided, okay? And once again, here is what I did on Wednesday. I had a NOR and, it had ABC inputs from the drawing that I showed you. And basically the not or was used for the AB inputs, and then the outputs from the not or, also known as NOR, were combined with the C input using AND. And when I do the truth table, I have A, B, and C, right? So I showed you how I developed the truth table. Here's A with half zeros and half ones, and then 00, 1, 00, 1, and then 0, 1, 0, 1, 0, 1 on the C. And if I'm taking A and B, I have to combine these two values to get the output here before I can AND it with C. How did I know what to do for NOR? I used my cheat sheet. So I went in here, and this is also in your, it's also in Blackboard. It shows you all of the outputs. Canonical summary is the name of this thing. A NOR is always 0 unless all inputs are 0, represented by one standard canonical, A tick, B tick. So then I went back to my truth table and said, okay, unless it's all inputs are 0, it's going to be a 0. So I had a 1 here and a 1 there, and then everything else was a 0. Then I took these outputs and combined them with AND, including the inputs from C. So if I look at AND for these combinations of values, we know what AND does. AND is always 0 unless all the inputs are 1. So, and it uses a standard canonical. So when I look at these combinations, I don't have all my inputs that are 1 here. This is 1, so I have an output of 1 here. All the rest of these are 0. The only combination that renders the 1 output, the original values were 0 for A, 0 for B, and 1 for C. The standard canonical expression is A tick, B tick, C. Any questions so far?
None.
Then thank you. I developed the logic for that. So when C is equal to 1 and A is equal to 0 and B is equal to 0, then out equals 1, else out equals 0. So there's only one case that has to be stated in terms of logic. I opened up one of my HDL files. Where is it? Really? I had it just a second ago. All right, so I opened up one of my HDL files, and then I saved as, and I used Notepad, and then I created my HDL. This is the part that I did last Wednesday that didn't. There you see the logic. When C is equal to 1, and A is equal to 0, and B is equal to 1, out is equal to 1 if, right? Else out is equal to 0. So that's my logic statement. I took NOR and then saved the file name NOR and the chip name NOR and. When I have 3 inputs, A, B, and C, and then I have a single out, for parts I have the 2 logic gates, not OR and. So the first statement, not OR, A is equal to A, B is equal to B, out is equal to W1. That's what you see on the diagram that I showed. And that's in the video. I drew the diagram and then saved it. I will look it up on my tablet, and if I haven't posted that diagram, I'll go ahead and post it just for reference. Any questions so far? So you see here, I'm using not OR. The custom HDL that I created to provide NOR functionality. And then the next line, I'm using the W1 for the A input. Now, if you instead show A equals C and B equals W1, you're creating a different chip than the one I demonstrated. And your diagram should show that, okay, what am I saying? I'm saying that the NOT OR uses A and B, and then the first input for AND is used with the output of NOT OR. Well, one way you can change up what I did last Wednesday is take the output of NOT OR and feed it into the bottom input of A instead of the top input of A. And you can flip this. And as long as your diagram shows that, it's not the one I did exactly, it's a different one. Another way to switch it up is to change the NOT OR so that the NOT OR accepts B and C instead of A and B, right? So that would mean that you're going to have different letters here and here, and different letters down here as a result too, because you moved where the NOT OR plugs in, and that would also be a different way of doing the same thing. All you're doing is making a couple of adjustments, and it's unique, and you can say, oh, that's mine, that's the one I choose to do. You can use NAND instead of NOT OR. The built-in chips provides a NAND. You could create a NAND AND or a NAND OR. You could flip it any way you want to, but that's essentially the piece that we finished up on Wednesday, and then we opened this and then tested for the case. So that's the last part of your solution submission. I have to run this in HDL, and then I have to enter the values to see if I get a 1. And then I have to enter some other values to see if what comes out otherwise is a 0. So let's do that now. That's the last part of it. I'm going to start my hardware simulator, and I'm going to load my chip, my NOR AND. All right, you see my name there, right? And you see there's a W1, and I'm going to, it said if A is 0 and B is 0 and C is 1. So I'm going to change C to 1, and I should expect the value to change. If I try any other combination, like if I try 1, 1, and 1, I'm going to shake my head and say, well, come on now. I fed all inputs 1. I don't get a 1 out. No, I don't. If I run this, I get a 1. That's a screenshot. That's the standard canonical case. This is what happens when I get the true. You know, I prove this works because there's my logic statement. There's my truth table. Now I run this. A is 0, B is 0, C is 1, and what I get out is 1. That's the first part. Now let's take a case where it comes out false or 0. I'm going to change A and B to 1 so that all my inputs are 1. If I did this right and I run this, I should get a 0 out of here. And I do. That's the last screenshot that you take. You can choose any of the alternate cases. For your logic gate, it may be that the false is the one case that's easy enough to show first. And then you just change the other inputs to show any of the other true combinations. You may get a different result. Are there any questions about how to run and check for function with your custom HDL?